Today, I'm going to give a really brief introduction on what neural networks are, because neural networks are basically the fundamental for understanding AI. Perhaps you have not heard of neural networks, but the functionality of these networks are utilized with facial recognition using the many pixels recorded. In biology, neural networks can help with disease classification and identification of biomarkers. Neural networks are the most specific term under AI. They are very similar to deep learning algorithms, but neural networks are just more simpler versions and deep learning algorithms have more layers. Deep learning is a subset of machine learning, and basically they just learn in different ways. And then there is AI, the broadest term, which is a word that umbrellas all things underneath the way that machines mimic human intelligence. They're called neural networks because they loosely model the neurotransmission of a human brain. Essentially, there are a bunch of processing nodes that are densely interconnected through channels. The first layer is where data is inputted. The next layer is where the bulk of the neural network resides, which is the hidden layer. The last layer is the output layer. Weights are assigned to channels, which is then added to a number that each neuron has, called the bias, and it calculates a value. The value is compared to a threshold number to determine if the input will be transmitted to the next layer. The value is essentially a probability in which the input will align with the highest value. However, to start the learning process, inputs have to be fed forward, hence the term feed forward. This is also called forward propagation. In this learning, which is also called supervised learning, an expected output is also known. So when the first input reaches the end, there is a certain value, and it's compared to what the actual value is supposed to be, from the example. This difference is called the error. The network will then adjust the weight according to the error, and these adjustments will continue until the output is similar to the target output. In order to actually achieve this target output, these adjustments consist of the information being sent backward, which is called backward propagation. In this way, the network is essentially trained through the use of a bunch of examples. Once fully trained, the algorithm will be able to recognize specific inputs, for example, an image of a dog. Thank you.